Alright, so let's get started with periodic table. Some properties which indicate the differences in elements are listed. So it's saying there's metallic character, number of electron shells in an atom, number of protons in an atom, and total number of electrons in an atom. Now we have to understand that metallic character comes from the ability to lose electrons. So things on the left side of the periodic table, they have a higher ability to lose electrons. Multiple factors go in there. They have less number of electrons in the large shell, so it's easier to lose them and become like noble gases. Similarly, the atoms are bigger on the left side on the periodic table compared to the right side. And as you go down, the ability to lose electrons becomes even more because the atom is getting bigger and bigger. Number of electron shells, obviously, they play a part in metallic character, but also the number of electron shells increases down the group because you are changing the period, and with higher number of period, that is accompanied by a higher number of electron shells. Number of protons in an atom, that's its atomic number, and that tells us the placement within the periodic table. And total number of electrons in an atom, which is exactly the same as protons in a neutral atom. So which two properties increase across a period? So you're going right on the periodic table, and when you go right, the size decreases, the proton number increases, and obviously the electron number also increases. But the number of shells, that remains the same. It doesn't change because in a period, the total number of shell is the same. Metallic character, in fact, decreases. So that gives me 3 and 4, which are going to increase across a period. Element X and Y combine to form an ionic compound. Atoms of X have more protons than atoms of Y, which means that it's either on the right side or below X. Atoms of Y have more valence electrons. So that clearly means that Y is in a bigger number of period. X have more protons than Y. So that means X is towards the right or below Y. So Y is either above or towards the left side. All right. And then atoms of Y have more valence electron. That shows that Y is a non-metal, which is above X, and X is going to be a metal. So if X is metal, it's going to form positive ions, and Y, being non-metal, is going to form negative ions. And why is it non-metal? Because if they're forming ionic compound, one of them has to be a non-metal, and the things on the right are non-metals. And because Y has more electrons in the last shell, it is more likely to be on the right. So ions of X are negatively charged, can't be. Atoms of X have more electron shells than atoms of Y. Yeah, that is true, because X, if Y is a non-metal, the next metal has to be in the next period or the period below that. So that is true. X and Y in the same period can't be true because X would have to be on the left side of Y, and that means X can't have more protons, and X and Y in the same group, that can't be true because they have more, one has more valence electrons than the other one. Elements in group 1 of the periodic table show trends in both their reactivities and the melting point. So just remember that down the group reactivity increases and melting point decreases, and that is because down the group reactivity increases because they have bigger atoms, so it's easier to lose electrons, and they have lower melting points because the metallic bond and the forces in there, they are lesser and lesser stronger, which is because the atom is bigger, so it's going to have weaker forces with the valence electrons. Which statement about the rubidium atom is correct? It has higher melting point than potassium. Potassium is above, rubidium is below, so can't be true. It reacts with water to produce an acidic solution. Actually, no, because group 1 metals react with water to replace hydrogen ion, which means they're going to produce a metal hydroxide, which is basic. So this can't be true. It reacts with water to produce oxygen. No, because they're going to replace hydrogen ions, so they're going to produce hydrogen gas. It is more reactive than potassium. Yeah, rubidium is bigger than potassium, so this is true. And why is it bigger? Because it has more shells, so it's going to be bigger, and it's going to have weaker forces of attraction with the nucleus and the last shell. It's easier to lose electron if you're a bigger atom. The properties of 4 substances are shown. Which substance are metal? Alright, so metals, we know the basic properties that metals are ductile, malleable. Metals have ability to conduct electricity. Metals have high melting and boiling point. So those are the usual characteristics we associate with metals. It conducts electricity when dissolved in water, but not when solid. That's not true because metals are good conductors in solids. It has a high melting point and conducts heat when solid. That is more likely to be a metal. It has a low melting point and is brittle. That's usually something we don't associate with metals. It has a giant covalent structure. Can't be covalent in some metals. So yeah, B is the answer. Group 1 elements and transition metals are metals. Student X suggests that group 1 metals are above hydrogen in their metal reactivity series, but not all transition metals are. We know that to be true because there is silver, there is gold, there is platinum, which are all transition metals, but they're below the uh, hydrogen in the reactivity series. Student Y suggests that the density of group 1 elements are lower than those of transition metals. That we also know to be true because group 1 elements have weaker forces of attraction compared to the lattice and transition metals. So they do have lower densities than those. So yeah, which of them is correct? Both of them are correct. A lump of element X can be cut by a knife, most likely to be a group 1 metal. During extraction with water, it floats, which means it is a group 1 metal, and melts because the reaction is exothermic and it has low melting point. What is X? Potassium. That's the only group 1 metal here. Chlorine is passed into separate samples of aqueous potassium iodide and aqueous potassium bromide. What are they going to get at is basically, does chlorine go and replace any of these halides here? And chlorine would replace that because this is a redox reaction. Chlorine is more reactive than iodide and bromide. And that is because chlorine is higher in the reactivity series than iodine and bromine. So chlorine is going to gain electrons, and bromide and iodide are going to lose that extra electron that they have, and then they're going to be displaced by chlorine in a redox reaction. So let's see in which solution there is a color change. Actually, in both of them there will be a color change because a color change indicates that there is an element that is colored and all halogens are colored. So iodine is going to come out because it is aqueous. Iodine is going to give us a brown solution, and bromine is going to give us a red brown solution. So we are going to see a color change in both of them. Indium is in group 3 of the periodic table, antimony is in group 5 of the periodic table. Which statement compares indium and antimony correctly? Antimony has more metallic character. Let's see. Antimony has a higher proton number and it is in group 5, while indium is lower proton number in group 3, and it also indicates that they're both in the same period, which means that towards the left side there's going to be higher metallic character. So indium is going to have a higher metallic character. So antimony has more metallic character is wrong. We're going to consider C or D. But we also know that antimony has a higher group number, which means it has more valency electrons. So yeah, this is going to be the answer. The position of 4 elements are shown in the outline part of the periodic table. Which element is a solid non-metal at room temperature and pressure? So solid non-metal is going to be over here. This is the staircase, remember, that divides metals and non-metals. So A is a metal and the other ones are non-metals, but which of them is solid? Down the group, melting point increases in halogens, so we know that D is going to be solid and we expect this to be iodine. 3 elements each show oxidation state of +2 and +3. This and in there tells us that it is going to be transition metal most likely. Number 1, they're positive, and number 2, they're going multiple valencies. So yeah, this is true. Let's go on to theory sections. Define the term element. So element is the simplest substance that cannot be broken down through chemical methods. Another way to explain this is that element has the same kind of atoms, and that is how you define element. Choose from the following elements to answer the question below. Each element can be used once, more than once, or not at all. So which element is in group 3, period 4? So you just go in the periodic table, locate it. So group 3, period 4, you're going to do that. Now remember that aluminium is usually the group 3 element that we all remember, but it's in period 3. So we're going to look below aluminium and we're going to find gallium, and that is going to be an answer. Now here's the thing, you should mention them in the way they have mentioned them here. So instead of writing its symbol, write the whole name as they've given here. So gallium has atoms with 8 electrons in the last shell. So 8 tells us that this is noble gas, so we have argon as a good candidate here. You also need to remember that argon is the 3rd most abundant gas in the atmosphere. Is a liquid at room temperature. There are 2 elements in the periodic table. One is mercury, one is bromine, and bromine is in the list. So these are the 2 that are liquid at room temperatures. Reduces unsaturated vegetable oil to form a solid product, that is hydrogen. That is something that you have to remember. Forms an ionic chloride with the formula XCl2, which means that X has a positive 2 charge because chloride is definitely a -1 charge. So +2 charge comes from group 2 or some of the transition metals. We have magnesium here, so that's a good candidate. How did I know that this is going to be a metal? Because it has ionic chloride. It's used in light bulbs, that is argon. Again, there are two uses of argon that we need to remember. One is used in light bulbs and the second is used in steel manufacturing. For each of the following, give the name of an element from period 2, lithium to neon, which matches the description. An element which is gaseous at room temperature and pressure. So from lithium to neon, we have neon, we have fluorine. Both of them are good. You could give fluorine or you could give neon. Now here's the thing. You might be tempted to write the symbol, but they have asked us for the name, which means we must write the name. An element which forms an oxide, that is reactant in photosynthesis. So it has to be a reactant. So that is going to be carbon dioxide. And it can't be hydrogen because hydrogen is not in period 2. So it can't be water because of that. So we are going to say carbon. Don't say carbon dioxide because that's not an element and we need an element. An element that is a product of photosynthesis. Again, an element, and that is oxygen. Remember that photosynthesis produces glucose and oxygen is an element. Glucose is a compound. An element that makes up 78% by volume of the air, that's nitrogen. The second one is oxygen, which is around 21%, and the third one is argon. An element which has atoms with a full outer shell, again, that is from the group 8, and that is going to be neon. Element which exists both as diamond and graphite. Could it be asking a simpler question? This is carbon. An element that reacts vigorously with cold water, we know that that is going to be from group 1, so we have lithium here. A soft metallic element which is stored in oil, again group 1, lithium. Lithium, sodium and potassium are elements in group 1. Francium is also another element in group 1. How many electrons are there in outer shell of a francium atom? They've mentioned it twice that this is group 1. So it's going to be 1. You can write the number, you can write the whole word. I'm just writing 1. And the next one, complete the following table about an atom of francium. So the group from the periodic table, you will find the proton number of francium. Now we know from the periodic table that francium is element number 87. And that is why we are going to get 87 as its proton number. And that is also going to be the number of protons and number of electrons. And then we'll subtract 223 and 87 to find out the number of neutrons, and that's going to be 136. Predict 2 physical properties of francium. So remember that this is group 1. So in group 1, these are soft elements and they have low density. They also have low melting points. So you can mention any of these 3. A scientist predict that francium reacts violently with water. Write the equation. So make sure you use the correct symbol for francium. Don't write F, that is fluorine, and it's a common mistake. Francium is Fr. So we'll write Fr element reacting with water. Now water is HOH. So it's better to remember water as H and OH instead of H2O because that's how the ions are. So francium replaces or displaces the hydrogen ion, giving us FrOH plus hydrogen gas. And now balance the equation. You have 2 hydrogen ions coming from 1 water molecule. There's only 1 hydrogen ion, so we'll need 2 water molecules. And that will give us 2 francium and 2 francium hydroxides. Rubidium is in group 1. It has similar physical and chemical properties to the other elements in group 1. Predict how many electrons are there in the last shell. So that is 1. One physical property of rubidium, which is the same as that of transition metal. So it conducts electricity. That is 1. That is true for all metals. Predict 2 physical properties of rubidium, which are different to those of transition metals. So again, it is soft. It has low density. You can also mention that it has low melting point because these elements, transition metals, they don't have low melting point. They usually have high melting point because the force of attraction in the metallic lattice is really strong. When rubidium is added to cold water, a reaction occurs, suggest 2 observations. And now this is different from the previous question because there they were asking for an equation, but here they're asking for observations. Now remember, observations are the things that you can see or hear or feel through touch. But usually we mention the things that we see, then we mention things that we hear, and then lastly we mention things that we feel through touch because we usually shouldn't be touching or tasting chemicals in the lab. So suggest 2 observations. So we could say that rubidium floats, again because it has low melting point. We could mention that there are bubbles, again, because hydrogen gas is going to come out. We could mention that there is a spark because the reaction is really exothermic. So you can mention that. But remember that even though pH increases, that's not an observation. That's something that you check or you test. So don't mention that. Similarly, the temperature rises. Again, that is something that we can check. This is not an observation you can make right away. Define the term diatomic. So that is made of two atoms. Usually we mention it for molecules. So you can mention the molecules made of two atoms. What do the electron distribution of halogens have in common? So they have same valence electrons, or you can also mention that same valence electrons number, which is 7. So all right, or you can say that all have 7 outer shells or something like that. How do the electronic distributions differ? So they have different shells. Do not mention that they have different periods, because that's not for electronic distribution, that's related to the structure of periodic table. All right, we have to complete the table. Remember that down the group, in group 7, density increases, melting point increases, and reactivity decreases. So chlorine is gas, bromine is liquid, and iodine is solid at room temperature. The colors, so earlier they used to mention that chlorine is yellow or green, and both were acceptable, or bromine was brown or reddish, both were acceptable. But now on, we should mention it exactly in the way it's done in the syllabus, that chlorine is yellow green. Don't say yellowish green, yellow green. Bromine is red brown, and iodine is gray black or blue black. Both of them are fine, but gray black is better. Two different atoms of sodium are sodium 23 and sodium 24. Now 11 is common in both of them because that's a proton number, and the bigger number is the nucleon number. Explain why these are isotopes, because they have same number of protons. So again, I'm just rewriting the definition for isotopes. You can mention the number here, but you can also say that they have different number of neutrons, and that is, you can mention if you want 12 and 13, but you can do without that. It's always a good idea to connect your answer to whatever information they've given in the question so that your answer is more specific. Sodium 24 is radioactive. It changes into an atom of different element which has one more proton. So again, this means that when it undergoes the radioactive decay, it changes the proton number from 11 to 12. So just go to the periodic table, find the element number 12, which is magnesium. Now, because they've asked us for identifying, they haven't asked us to name it, they haven't asked us to write the symbol. So we can say magnesium, or we could say Mg. Both of them are acceptable. State two uses of radioactive isotopes. So one use is that we could use it to produce energy, so energy production, or we could also use them to treat conditions like cancer. All right, so you could mention both of them. Now your answer have to be specific. Don't just say they're used in medicine, because that is quite vague. Like, how are they used in medicine? So that is why it's better to write what they're used to treat or how they're used in there. That's important, because in many scans we also use them. So you could also use them industrially to detect leakages. So it's important to mention your answer in a way that is exactly right, instead of being vague or alluding to a certain thing. All right, so that was group 1, group 7, and the general structure of periodic table.